this lesson today, we are going to be going over chapter 3.7, transformations of polynomial functions. And we actually went over transformations before. I Googled transformations and it came up mostly with transforming houses. And I saw this picture, I thought it was interesting. So this house went from this to this. So pretty cool. I wish I had pictures of some stuff my husband's done because he's done stuff similar to this before. Okay, so remember these, the function transformations. Okay, we've got these 5, and I'm going to write down those transformations for you. So a vertical translation, remember translations either go in a horizontal direction or a vertical direction. Your vertical translation is f of x plus k. So it's your function, and you're either adding or subtracting, going up or going down. That's probably the easiest one. If you're moving left to right, then you've got f of x minus h. So you have to put x minus h in for every x in your polynomial. Those get a little tricky. Okay, reflection in the y-axis is when you just take the whole polynomial, the whole function, and multiply it all through, distribute a negative. Okay, reflection in the y-axis, you take every x value and replace it with a negative x. And finally, your vertical stretch and shrink is when you take what you're multiplying it by, or what you're stretching or shrinking it by, and just multiplying it by the whole function. So you need to memorize these. Obviously, you had to memorize them from before, so I'm hoping that you remember. These are going to keep coming up, not more and more, but occasionally they'll come up for the rest of the year, so you'll want to know those. Okay, so when I think of transformations, I think of like a map. So here's downtown Provo, and let's say I'm starting, at 5th South and 1st West, okay? So this is my original function, and I say, okay, I need you to go up 4 blocks and then to the left 1 block. 1, 2, 3, 4, and over here 1 block. My new address is 100 South University Avenue, right? It started off as 100 West, 500 South, okay? But it ends up here. So when I'm doing my transformations, the functions I start with is where I start, and then when they say, stretch it by this much and move it to the right that much, those are your directions. And then finally, your end result, your g of x, is your new location. Okay, so there's a lot of graphing in this. I encourage you to do as much graphing as possible. I know it can be kind of tedious, but do your best. So, okay, so I did all these already. Describe the transformation of f of x equals x cubed, represented by g of x equals x plus 5 cubed plus 2. So what is it that's happening from here to here? I started in this place on the map and I ended up here. Okay, well, remembering back to those transformations that we have, and these specifically are translations. Okay, we're going up 2 for sure. So we're going up 2. And then are we going left or right? We're going left. Okay, because this is the same thing as x minus a negative 5, and negative numbers go to the left. So this is up 2 and left 5. Okay, if I graph x to the 3rd power, I have 0, 0. If I plug in negative 1 there, I get a negative 1. If I plug in a 1, I have a 1. If I plug in 2, 2 cubed is 8, so that's 2, 4, 6. That's way up here. And if I put in negative 2, it's going to be negative 8, which is 2, 4, 6, which is here. So this is basically what x cubed looks like. Okay, and what happens here is it has now moved up 2 and to the left 5. 1, 2, 3, 4, 5. So if I kind of do similar dots, okay, so this next one would go down 8, 2, 4, 6, 8. This one would go up 8. Oh, I'm sorry, from here. So 2, 4, 6, 8. And from here, 2, 4, 6, 8. So my new function, g of x, oops, kind of missed it. Anyway, it's going to look like that. So my function started here, moved down, moved up. All right. So now I want you to try this one at home. Do your best to graph it. I know you probably don't have graph paper, but just do your best and try it right now. Okay, so x to the 4th power, which basically looks like a parabola. It really does. It's been kind of flattened out a little bit. Maybe you put this into Desmos. That's actually a great idea, is to put this into Desmos and look at the two of them. Okay, so we have x to the 4th represented by g of x, x minus 3 to the 4th minus 1. So we have it going down 1, and it's going to the right 3. Okay, so if I graph this really quick, I have 0, 0. If I throw in 1, I have 1. Negative 1 is in negative 1. Then it gets really, really big, really, really fast. Okay, so there's that. Now if I go to the right 3, 1, 2, 3, and I go down 1, then I can draw similar coordinates. Okay, so that's what that looks like. And this I need to do more on the next video.